Hey class, welcome back. This is lesson 11-4 and today we're going to be talking about the volumes of prisms and cylinders. That's right, we are finally going to be starting volumes. So, first thing we're going to talk about is the volume of a prism, or you guys can think about this in basic terms as the volume of a box. So the volume of a prism is going to be the product of the area of the base times the height. So volume equals base area, that's what the big B means, by the way, base area times the height. Now, I just want you guys to remember, when we talk about volume, we're not talking about area. We are talking about the stuff inside. So volume is all the stuff inside this box, right? It's not the outsides, it is the insides. So everything that could go into this box. And we're going to be using cubic units to talk about volume. So what is the volume of the rectangular prism below? Well, we've got one side measuring 24 centimeters, one side measuring 20 centimeters, one side measuring 10 centimeters. So what we're going to do first is find this base area down here. And we can find the base area by doing 24 times 20. And then we're going to multiply that by the height, which as we can see back here is 10. So when we multiply all that together, we're going to get 480 times 10, which gives us 4,800. So the volume of this rectangular prism is 4,800 centimeters cubed. Let's try another one. This one's going to be harder. In this case, what is the approximate volume of the triangular prism? So now, notice, it is a box still, I think you guys can see that, but one of the bases is a triangle. The other base is also a triangle. The one nice thing about these triangles are they measure 8 by 8, and if we look over here, by 8. So all three sides are each 8. So the first thing we need to do is find the area of the base of the prism. And the fact that this is an 8 by 8 by 8 equilateral triangle makes this a lot easier. What we can do is split it right down the middle. Now we know that an equilateral triangle has angles of 60 degrees because 60 plus 60 plus 60 equals 180. So, because the hypotenuse is 8, and we've divided this thing down the middle, what we wind up with is a 30, 60, 90 triangle on the left half of the triangle. The hypotenuse is 8. Remember that the hypotenuse is 2 times the short side, so the short side must be 4. And the long side, or the long leg I should say, is root 3 times the short side, or in this case 4 root 3. So the height of this triangle is going to be 4 root 3, which we found using that 30, 60, 90 triangle. The base of the triangle, of course, is 8 inches. So what we're going to do is use that area formula. So base area equals 1/2 base length times height. And that's going to give us 1/2 times 8 times 4 root 3. 8 times 4, that's going to be 32. We divide 32 by 2, and that's going to give us 16 root 3. So that is, again, the area of this triangle is 16 root 3. Now, we're going to find the volume of the prism using volume equals base area times the height. So we plug in 16 root 3 as the base area, 10 as the height, because the distance between these two bases is 10 inches. And that's going to give us 160 root 3, which is approximately 277 inches cubed, or cubic inches. So our best answer here is B. I want you to notice, in the end of the last two problems, our answer was in cubic units, not square units as we've seen with area and surface area. So next, let's look at volume of a cylinder. Now I want you guys to think, first of all, the volume of this is exactly the same as the volume of the prism, meaning it's still going to be base area times height. It's just that now the base is not a rectangle, not a triangle, but a circle, which we know we can find the area of using pi r squared. So our volume is going to be base area, which is pi r squared, times the height of the cylinder. we could as a demo of this, I want you to imagine that you took a penny, and that would be kind of like the base of this thing. And then you added a bunch of pennies on top of each other, like going up and up and up and up until you got to the height that you wanted. What we're basically doing is adding all those pennies together to create the whole cylinder. So, our question here, what is the volume of the cylinder in terms of pi? Now, they gave us a radius, they gave us a height, so we have all the information we need. Volume equals pi r squared h, right? Because this is the base area, and this is the height. So we plug in r, which is 3, we plug in height, which is 8, we get pi 3 squared times 8, which is going to be pi times 9 times 8, which gives us 72 pi. That's it. Very straightforward. You need a radius, you need a height. Once we have those, we're good to go. It's just that simple. Now it gets more complicated. This is what we call a composite figure. I want you guys to check out this aquarium really quick. Notice the height is constant throughout, right? Same height all the way around. The width back here is 24 inches. The length here is 48 inches, but notice something. At the front of the tank, at this point forward, it starts to curve. So, we're going to break this up into a prism, a rectangular prism, which is going to be super easy to find the area of, or sorry, the volume of. And then we're going to have this half a cylinder. So notice, because it's half a cylinder, it's 24 inches wide, and it's 24 inches tall, but it's only 12 inches kind of thick. Because we don't have that other part, that other radius's worth of cylinder. So, we're going to go through the motions. First of all, on the left side, we're doing the volume of the prism. That's going to be pretty easy. 36 times 24 times 24 gives us 20,736 cubic inches. On the other side, this is half pi r squared h. Now remember, r is 12. H is 24, so we put this all together, half pi 12 squared 24, and that gives us approximately 5,429. We add those together, and we get about 26,165 inches cubed. The part of this problem where I assume most of you will get the most hung up is right in here, the half cylinder. Okay? The key here is that we're not using the traditional volume. We are multiplying the traditional cylinder volume by half because it's only half of the cylinder. So that's, I think, what's going to throw off the most people. Just remember, we're only doing half a cylinder, so we're only taking half the volume. Homework tonight is going to be page 1649, number 7 and number 12, and page 1650, number 15. I'd also like you guys to take a look at the 11-5 slides. You might notice the pattern here. Next time we're going to be finding volumes for pyramids and cones. Gentlemen, I'll see you next time, and good luck.